Okay, Assalamu alaikum class. Today we are going to start on the pressure, temperature, humidity sensor, that is BME 280. Okay, BME 280. So basically, this is a barometric pressure sensor that we can measure the pressure in the atmosphere, like 1 Pascal, 2 Pascal, okay, 3 Pascal, 76 millimeter, something like that. So the pressure that exists in this room throughout the air, that we can measure with the BME 280, and this is an integrated sensor. Integrated sensor means you have some integration with the sensor, like what is mobile? Mobile has some integration of systems, like you can use the app, you can use the calculator, you can call over the phone, and you can show some videos, capture photos. So this is an integrated sensor. Like in this sensor, it is not only occupied for measuring the temperature, okay, but it's also calculate the temperature and humidity as well. Okay, like I'm feeling very hot right now. Okay, I'm feeling very cold. So the humidity around my surface, around my circumstances, can be measured with this sensor. Okay, so it's not I to C, it's basically I square C. It's I square C. I square C. I square C bus driven 5-volt BME 280 sensor breakout board. So this is a breakout board, I mean a PCB board, where you can add some male connector by soldering this, and you can take out your connections that has been connected with the microcontroller or other device. Okay. So as a basic, every sensors need two things, two connection, that is power and ground. So to power up this sensor, you can use 5-volt, 3.3 volt or 5-volt, and there is a level shifter over there, and that shifter is something like that can shift. Basically that shifter is very much important just to calculate some voltage. Like you can if you put 4 volt over there, that sensor will be running fully. Okay, if you apply 5 or 5.5 volt over there, the sensor will be running very smoothly. Okay, and the sensor is something like this. So ultimately this is the sensor, this small chip, and all these items or all this breakout board is something a PCB. So the connection has been made throughout this layout. See, throughout this layout with the copper conduction, with the copper conductivity. Fine. Now this is very small breakout board just to ensure that it can measure the temperature, it can measure the humidity, and it can measure the pressure as well. Fine. Now the thing is, it's a 5-volt breakout board. So if you want to apply more voltage, at the time being the sensor could be burned. Okay, so every sensor or every item has its own capability. So that's the basic things that has been used over there. Okay, and so the schematic diagram is something like that, how it works actually, and you can see LV1, LV2, LV, LV3. What does this mean? LV1, LV2. This is a level shifter. Okay, there's different type of level shifters over there, and this is the basic of a sensor that we have discussed earlier, and I'm just have just basic discussions over there. So I2C bus 5-volt MPU 6050. What? MPU 6050. It's a gyroscope. Okay, so you have a phone over there. Okay, so if you feel that the phone is letting down, so if it's X, it's Y, then it will be Z, right? X, Y, Z, another dimension. So 3 dimensions over there. So the phone can be rotated like this. So phone can be rotated like this. So the phone can be rotated like this or different direction. So you have a base over there. This is the base. So if it moves like this way, can it feel any kind of angle? I think not. So if it moves like this, so it will create angle towards the x directions. Okay, so if it feels like this, so it will create the angle to the y direction. Okay, if it feels like this, so it will create an angle to the z direction or z directions. So with the help of the directions towards the with the help of the angle towards the directions or towards the axis, you can calculate that where it turns from the basic, from the null point, from the 0 point. Okay, where it has been turned. So you can calculate the angle as well. Fine. So that's a very basic chipset, I mean the PCB. So this is the MPU 6050. This is the ultimate sensor, and there will be some level shifter, a ground, maybe a ceramic capacitor. There is a regulator voltage over there. Okay, so that's it, and it uses, I mean, it's based on the MEMS technology, not the meme that have been shared on the Facebook or Reels. It's MEMS technology. MEMS means microelectric mechanical system. So why this is microelectric mechanical system? Because it's very much small in size, so that's why it's micro. Electromechanical means, see, whenever it creates the angle, there is some effect on the electromagnetic field over there. So that electromechanical system has been developed, all the sensors and all kind of devices, if it has an input or impact on the electromechanical system or ultimately electromagnetic field or something that has been developed over there, so it goes on this subject, that is microelectric mechanical system. Fine. So what this sensor does? This sensor measures acceleration. Acceleration is speed. How much fast you can run towards a particular directions. In every changes of speed. Velocity means every changes of what? Distance according to the time. Velocity, orientation and displacement means the rotation, the angle, okay, and many other motion related parameters of a system or a subject. So it's not only something that can creates an angle, creates the orientation or changes the orientation or take the value from the displacement. It's not something like that. It is beyond over there, and it's 3-axis acceleration and 3-axis gyroscope. So you can run towards this x-axis, like I'm running towards now. You can run towards the y-axis, and you can jump actually. So if you jump over there like this way, so it will be create some angle, okay. And on the other hand, you can go to the z-axis. So that angle is x, y, z, x, y, z. So so you can run towards over there like a Spider-Man, you can run towards over there like a Spider-Man, you can line towards over there, you can run or walk over the wall or stick into the wall. So that's the acceleration can be measured over there. And the another thing is 3-axis gyroscope. So as I've mentioned, with the use of the mobile phone, you can take the value like a compass, so how it creates an angle. So that's the main thing. Without this, you cannot take any value or cannot execute any value. Okay. So now you have to put in concern that it's a integrated sensor where you can use the gyroscope and the accelerometer as well. Fine. Okay. So the most important part that can be important for the exam, that's load sensor. Okay. So it's a Western bridge type sensor, and it produces a DC output voltage proportional to the weight placed on it. So ultimately, just a second. Okay, so It produces DC output voltage proportional to the weight placed on it. So, the point that is our concern is like if it comes to a sensor and I am giving some weight over there, so the more I can put the weight over there and then the more I can gain the voltage. Okay, see, it produces a DC output. So, DC output means what? 3 volt, 5 volt, 3.3 volt, 3.33 volt or something like that. So, ultimately what we want to see actually, the voltage or the weight? What is our main output? Voltage or the weight? If you stay or put on the weight machine, you want to see the voltage or the weight? Weight. So, ultimately this weight converts from the voltage. Okay. So, there is a cell over there. This cell actually works in the cantimeter load type cell. This is a cantilever load type cells. There are different type of cells over there and we don't have any kind of concern on that. We have to just focus on this 30 kg load cell. So, ultimately if you have the full setup, you can't work without this load cell, and if you have just only the load cell, you can't have the ultimate output. Why? Because the load cell have some values that create the voltage, but how you may convert this voltage to the weight. So, you need a proper system, right? And if you have a full system, but you don't have a load cell, how will you take the input as a weight, right? So, ultimately the more you will put the weight or the mass according to G, with G is proportional to voltage or something like that, right? That is it. So, ultimately 10 millivolt signal when 30 kg weight load is placed on it. So, if you put 30 kg over there, so it will produce what? 10 millivolt. So, now the question is, what will be the per unit voltage according to the per unit kg per load or weight per load per unit? What do you mean by per unit? In 1, so what will be the ultimate voltage signal in per unit kg? Ten by 30, I mean 1 by 3. So, what is the result of 1 by 3? What is the result of 1 by 3? 1 by 3 is means what? 1 by 3. The number in fraction 1 by 3. Put the value in the calculator 1 by 3. 1 by 3 means what? Okay. So, there is a mounting screw over there and there is a load over there. I mean, you can set up the load over there. There, and see, if the machine is something like this, if you stand over there, so it seems that this portion will take the input of your weight and there is a mounting screw and these are the sensor signals and the output voltage. You can't say 1 by 3 means what? It's 0.33. So, what is the answer? How much voltage will produce over the per unit weight per load? 3.33 volt, simple. Volt or millivolt? Millivolt. So, 3.33 into 10 to the power minus 3 volt. Okay? Fine. So, that is very basic, as I have told you earlier that how it works actually, and what will be the procedure of connections, what will be the significant integrations of these connections and how this works. See, you will find 4 wires over there, 4 wires. One will be the green, one will be the red, another will be the black, and there will be a white wire as well. Fine. So every wire signifies different type of connections throughout this HX11 based ampere plus 24-bit ADC circuit. Why? Because these signals should be converted. So this will be the analog to digital converter. So you have to use the converter. After converting the signal, how you may show the output. So these signals and this voltage should be processed. Is that so? So the processed or the processing will be occupied or will be observed in which sections? This processing unit, isn't it? So that's it. And after that, is there any kind of display or output to this processing unit? Is there any kind of display output in this processing unit? Can you show the output over there to the Arduino? Any monitor, any display over there? Where? Where is the display? Yeah, there will be no display over there to the Arduino. So, to show the output, you have to use the print function in the code just to show the serial monitor. Or if you have the laptop or PC, by coding or while doing the code, you can show the output in the what? Monitor. And if you are going to use the 7-segment display, if you are going to use the I2C LCD display, you can also show the output over there. Okay? So that's a simple thing you can work. So how it works actually, see, is the Arduino Uno, right? Okay. So it's the Arduino Uno, and this load cell is going to calculate the load over there. Over there, okay? So there will be a gap. So this is the cantilever type load cell. So there will be a gap over there, and see, this load cells is only for 0 to 30 kg, right? So what will be the maximum value for this load cell in terms of voltage? What is the maximum value of this 30 kg in terms of voltage? What will be the maximum value? 10 millivolt, exactly. So 10 millivolt can be produced as maximum because it has the capacity of 30 kg. Now, if a person who has a weight of 45 kg and if he stands over there, what this machine will show? This is a very common question. What this machine will show? Sorry? Exactly. There will be some error function over there that can be run over there because it has the capacity of 30 kg. Okay. So this particular voltage have to manipulate. This particular voltage has to manipulate, has to be observed. How? And has to be processed. How? With the HX11 24-bit ADC, right? 24-bit ADC. So now this is a basically a ampere based circuit and a analog to digital converter. ADC means analog to digital converter. So this analog to digital converter is very much important over there, just to ensure that there will be two input and 2 output from the sections. So the green and the orange, this particular plus minus will produce the signal and send it to the CSCK, I mean clock and the DT, okay? And this sensor should be connected with plus and minus, and that plus minus, I mean E plus and E minus will be connected to this plus and blue. So white one is the plus and the blue one is the minus. So it varies actually. If you take the modular and search on Google, you will find their plus minus according to this. So every time you will find how many wires? 4 wires, and every 4 wires has some significant meaning of that. And that meaning should be varied according to the load cell. So if there is a load cell, you have a load cell of 40 kg or 50 kg. So the color wouldn't be the same, but the result or the occupation or the execution is ultimately the same. Fact is, you are connecting over there, and as a matter of fact, this one has to be connected with the particular voltage. So you have to power up this HX711. So if I show something that what is exactly HX711, so it's very cheap device, and it has some two selectable differential input channels. Okay, two selectable differential input channels. So the differential input channels, most probably the A plus and A minus. Okay, A plus and A minus. So input channels. Okay, let me see. Where is it? It has some. Okay, so the input channels A plus and A minus, exactly. See, the thing that has been coming towards this direction, so there will be the input of there. So the output will be the input of this channel. So A plus and A minus. Okay, I'm right. Fine. And another thing is something like there will be some plus minus, B plus and B minus will be connected to the battery, and the other as well to the another connections. So this is the ultimate chipset that is working as a 24-bit ADC and as well as the ampere circuit. And there will be some ceramic capacitors over there, C7, C8, C5. There will be resistance over there, small amount of resistance, I mean small number of resistance, R1, R2. Okay, it's a very small circuit, and there's a switch most probably, or a level shifter or something like that. Okay. So see, on-chip active noise, PJ with a selectable gain of 3264. Okay, it can active noise on-chip accelerator, external component, on-chip power step. So the resolution is 24-bit. It's 24-bit means, do you know about the resolutions? I have talked about the last class. So if you get the resolution of 8, it means 2 to the power 3. So 2 to the power 4 means what? 9. What? 4. Yes. 16. 2 to the power 5 means 32. So ultimately it has a 24-bit resolution. Okay. So if you divide these sections in a bit, so in every number of bit or in every number of sections or room, you can set your value over there and can find your ultimate 24-bit. So how it works? This dual channel 24-bit precision AD weight pressure sensor load cell amplifier and ADC module is a small breakout IC that can be measured weight. So this circuit has been used for the basically to calculate and to measure the weight, and in the microcontroller you will be able to read the changes in the resistance of the load cell with some calibration. So the thing is you have to calibrate this sensor. Okay. So what is the meaning of calibration? It's something whenever you are working with a new device in a new environment, so you have to set to a null point. Okay. So it won't gonna be work like if you put your phone over there like to the load cell and you get the value. So you have to make him understand that it's 0 right now. Okay. Whenever you are going to understand him that it's totally 0, there will be no weight over there, then you can put over there. See, every time you went to market and you want to buy some things, the shopkeeper will take the value of the 0 and make it null, then he or she puts the weight over there, then the machine will going to calculate. Okay. So every time you need to calibrate actually. So that's the same thing, you have to have some calibration over there, and in terms of initial calibration, after that you can work on it very much smoothly. Okay. Without calibration you won't get the particular value and the particular weight. Fine. So that's the thing, that's how the things works actually, and obviously it creates the value of ADC, so analog to digital converter, and it will going to be connected to the A0 and A1, I mean the analog pin of Arduino, as I've told you. So that's the thing, and you can power up the same thing 5 volt and 0 to this same point, because if it works at a source 5 volt or 0, a battery or something. So in parallel, you can power up these things and the power of this Arduino Uno as well. Okay, so that's the very much important thing and very much easier thing that you can see over there. And if I tell you actually to build up a circuit or something that will be calculated the load and with the serial bit and show the ultimate output, then you have to work on that. Okay, so A0 is something like serial clock. SCLK, it means S for serial, CLK means clock. So serial clock is very much important, and A1 is serial data. So every time it will generate two type of values, two type of data, and you have to work with the serial clock and the serial data. Okay, and the other thing is 5 volt and ground. Okay, so this is the sensor, and to the why it's dual channel, because you can work with the sensors and you can work and process same time as well. Okay, so that's why it has two channel, not a single channel, one channel, two channel. Okay, so it's very much important. I won't express that HX11 has to be used over there, and if I tell you that you have a load sensors of 30 kg inputs and you have a dual channel dual channel serial converter. Okay, serial converter is basically a converter, serial analog to digital converter. So you have to make a circuit with the particular display. Okay, so in terms of display, what we will use? Are you going to use the SM serial monitor? No. So you will write over there display. Serial monitor means you have the laptop or PC or the computer, and you put and you upload the sketch over there, and then you don't need any external display. So your display, your laptop will be worked as a display to the Arduino sections. The Arduino has its own range. If you click over there, this serial monitor, then there will pop up over there, and the things that was or that will be going to be shown on the external display to the LCD monitor or 7/7 display, the same thing can be shown as output to your laptop or PC. Okay, so you can test over there whether it will work on the display or not. So that's the primary thing, and that's the basic setup of our Arduino. Okay, so that's how it works, and that's very much important thing. And I have talked about the calibration, and the calibration is the most important fact, because without the calibration you can't work with the sensor, right? So how this calibration works? Do you know about the linear equation? Y is equal to mx plus c, y is equal to mx. মূল বিন্দুগামী সরলরেখা সমীকরণ. The line that intercept the 0. Okay, see what is the starting point? 0 0. So what is the starting point? 0 0. Then what? 15 and 5. 15 and 5. Okay, and then what? 22.5 and 2.5 and over there. See? 7.5 or something like that. So let's, okay, that will be 7.5. So this is the millivolt in y-axis, and in x-axis this is what? Weight. How this weight measures actually? What will be the top value over there? Tell me, what will be the topmost value over there? 10 millivolt, exactly. So will be 10, as I have written over that millivolt, so you can write the 10 over there. 10, fine. So what will be the most output or the maximum value in the x range? 30. If I use the 30 weight, 30 kg weight in a matter of cells in calculations, in terms of calibration. So you will get different type of like this will be U, V, W, X, Y, Z or something. Okay. So every time you will get some coordinates in Bangla sthanonko. Okay. So what will be the coordinates over there in terms of x-axis? It will be 15 and 5. In terms of x-axis and y-axis, 22.5, 5. Is that so? Okay. Oh, sorry, 7.5. So is that so? Yes, it is. So the response curve of an ideal sensor passes through an origin and make 45-degree angle. So in terms of this equation, what we can write is this y is equal to mx. So, if there is c, c will be the 0. This is the equation of y is equal to mx plus c. Do you remember? So, this part is the c. So, if this c is equal to 0, it means y is equal to mx, right? C0 means what? This line will be congested and lean down and get and cover up this 0, I mean these equations. Okay? So, this is the ultimate thing. So, is that easy to now? Is it easy to understand right now? So, I hope after the class you can make a very good output over there. See, it will 0 output voltage when no weight. So, ultimately 0, 0. I mean, if you are not putting any kind of weight, it will show 0. So, that is the calibration. That is the thing you have to do over there. If there is no weight, it shows that there will be 7.55. Is that okay, or the sensor is mentally sick? So, the sensor is ultimately it will just is not well, and it will sick basically, because there will be 0 over there if I put 0 weight on it. So, what will be the significance of y is equal to mx? See, mx, m means what? Tan theta, right? So, I will prove the 45-degree angle over there right now. Okay. So, y is equal to what? Tan theta x. So, tan theta means what? Y by x, right? So, theta means what? Tan inverse y by x. So, this equation is going to work if there will be a 0, 0 over there. So, what will be the angle over there? Take out the calculator and write what is the value of tan inverse 1. Tan inverse 1. It's 45-degree. I mean, tan 45 degree is equal to 1. Tan 45 is not degree, tan 45 is equal to 1. So, ultimately, if you get some 0 over there, and it is the line that intersect the main point, I mean the center point, then you have to declare that obviously it will create an angle, and that will be 45. Is it? If it's something like 45, if something 45 and it will be 55, is that so? Or the 45 will be the 45 is all the time, it will be creates 45 angle. It does not matter how much spread or strand out these two lines, see. So, it will creates 45 degree. Okay. So, that is the calibration, that is how we have to work on the APSICA, actually the response curve, the ideal, that is the ideal response curve. If there are some problems over there that you are not getting the 45 degree, so it would be something like what, 43 degree angle, 44 degree angle, then you have to set and tune that voltage, tune that weight and comes up to the 45 degree, or much, or at best you can do as to make it 45. Okay. So, there will be some known as offset or something that that is not going to be discussed today, and I hope you have understand the whole summary and the whole thing, and how this you will understand that this will be the ideal response, but in real response it will get something like that. Okay, I am going to explain it in a very short way. See, that is what the ideal one, that should be, but in real life there are some problem, the malfunction, some dust, okay. There will be lots of values over there, and that is why you will get the curve over there. So, that time y is not will be exist in y is equal to mx, then the plus c will be added over there. See, plus c will be added over there. That c will convert as a offset. It's offset value, I mean offset voltage. You have learned or heard about this offset term. Okay. Basically, it's a pulsating DC voltage that push up the signals or that create the signals and make larger or make a whatever you can say. It's a parallel voltage or a parallel line throughout the x-axis that creates impact to the real line. See, offset value means it has a significant role, like it will be 3 volt, 5 volt, 7 volt. So, if it's a 5 volt line, so it will be 3 volt voltage. What kind of voltage? So, my line is over there, and if you get something lines over there, then ultimately this voltage, this range will create this line. So, this is the ultimate fact how you will get some ultimately offset 1, and this will be the offset voltage. So, what? So, offset will be something like 5.1 or something. Okay, if it's 5.3, it's 5, it will be 5.2. Okay, so this 5.2 offset voltage comes from where? So, yes, there will be some finite amount of output voltage where there is no weight placed on it. So, if you don't place any kind of weight, so at the initial point you will get something like this offset voltage, and that is the problem I have talked earlier, and that is why the values has been changed, the response has been changed. Okay. So, calibration 1 was the basic calibration, and calibration 2 is now the second basic calibration. How you have to tune this one, you have to make sure that yes, that is going to work over there with the particular in concerning of the real response curve. Okay. See, so this will be the ultimate real response curve, and every time the value will be changes over there. 5, 5.3, 7.5, 7.9. So, it will be 0.3, 0.4 more that has been observed from this offset voltage. Okay? Yeah. That is the thing you have to learn, you have to calibrate. So, there is a formula of calibration. So, W is equal to FC is the basic formula of basic formula of what? Linear equation, I mean straight line equation, like x minus x1 to x minus x2 is equal to y minus y1 divided by y1 minus y2. See? Okay. X, x, y, y1. X, x, y, y1. Minus y1 or y minus y2. Okay. They have used the C1 over there. So, ultimately we can work with this sensor with the work with the value, and this very important thing to know about the calibration of the sensor. So, the calibration is very much needed over there just to ensure that how the real life weight machine works, and how it gets the value and how it shows the output. So, it is not mandatory that you have to use the Arduino inside of the machines, but in terms of basic or to understand the things, understand the stuffs, you can use the Arduino. Okay. So, that is it for today, and to the next class we will learn about this equation and fact, the gain factor and the offset, and the BME sensor as well. Okay. So, you have one class left just to ensure the syllabus has come to up to an end, and yeah, that is it. Okay. Thank you for today. Assalamu alaikum. Please turn off the video. Turn off the video.